An unknown powder, that sounds familiar, was found at a crime scene. This time it is your job to identify the chemical formula, which means molecular formula. That was a good question from before. And its common or generic name by searching the internet. Preliminary tests reveal that the possible elements that can be in the material are carbon, hydrogen, oxygen, and nitrogen. Complete combustion of a 0.45 gram sample of the unknown powder with excess oxygen produced some grams of carbon dioxide, some grams of H2O, and some grams of N2 or nitrogen. The molar mass was found to be about 151. Now let's find the process. So a student was asking before about what was the most elaborate problem like this that could be on the exam. It's this. So this problem, or this type of problem, could be on exam. And I will talk more about your exam next week because your exam is 2 weeks from now. So next week I will have your exam written and I will be able to answer some questions about the format of the exam. But for now, this type of problem could be on your exam. We have, all right, so, but let's work it. In this particular type of problem, we have grams of CO2. We're going to turn those into moles of CO2 and then moles of carbon because carbon is what we need in our formula. We said earlier that the molar mass of carbon dioxide was 44.01 grams per 1 mole. And in 1 mole of carbon dioxide, there is 1 mole of carbon. We will find moles of carbon, and I'm going to go ahead and do this. 1.0481 divided by 44.01 is 0.0238. And that's moles of carbon. And for this problem, so we need moles of carbon to find the empirical and molecular formula, but we also need grams of carbon to do the find oxygen by subtraction. So we'll do both. Multiply times 12.01, I get 0.286 grams carbon. Do the same thing except for H2O. I have 0.2414 grams of H2O. Molar mass of H2O is 18.02 grams. Per mole of H2O. And then in 1 mole of H2O, there are 2 moles of hydrogen. So I'll multiply this out. 0.2414 divided by 18.02 times 2. I get 0.0268 moles of hydrogen. And we will turn those into grams of hydrogen. And I actually don't normally do it like this, but I'm really enjoying this having my grams in a different color than my moles, because that allows me to classify later in the problem and separate these numbers. I don't usually do that, but this is a new wrinkle or a new addition to my technique. equals 0.0270 grams of hydrogen. Because my biggest problem in solving these, especially for these, for hydrogen, but sometimes for carbon as well, is I'll look and pick the wrong number later in the problem. Okay, so now on to the hydrogen. The hydrogen is on the same size sample, so good. Now I'll do the same process I demonstrated last time, which is 0.0417 grams of nitrogen. There are 28.02 grams of nitrogen per 1 mole. And then in 1 mole of N2, there are 2 moles of N. And that 2 does make a large difference in finding your empirical and molecular formula. So let's see. So that's why, even though it seems relatively straightforward, I like to do the whole calculation out. Divided by 28.02 times 2. 0.00298. Moles of nitrogen. And if you were to do this and multiply it times the molar mass of nitrogen, you would get this number back. 0.0417, because this is all nitrogen. So however you do it, that's the grams of nitrogen. Now we're ready to find oxygen by subtraction. When you find oxygen by subtraction, you start with your sample size, 0.45 grams. And I'm going to add a couple extra zeros on that. And then subtract off my grams of carbon, subtract off my grams of hydrogen. Subtract off my grams of nitrogen. And I get 0.095, 3 grams of oxygen. Sorry, I went off page there. There we go. There's my setup. And then molar mass of oxygen, 1 mole of oxygen. .00596. Moles of oxygen, like so. And now I'm ready to write down all my moles of things. Again, you don't have to do it this way, but this helps keep me organized. So coming up to the top, I know my moles of carbon was 0.0238. My moles of hydrogen was 0.0268. My moles of nitrogen, 0.00298. And oxygen, 0.00596. Now I can divide through by everything by the smallest number. Smallest number is this number for nitrogen. This number here for oxygen looks like it's going to be a 2. And I don't know what these numbers are going to be, but these numbers are going to be closer to 10. All right, multiplying this all out, so N is 1. Oxygen is going to be 0.00596 divided by 0.00298. 2. Perfectly. I like it. And I will get back on screen. Now, hydrogen is going to be 0.0268 divided by 0.00298. 8.99, so 9, and 0.0238 divided by 0.00298. Good. 7.99, which is 8. That is my empirical formula. Now the next question is it my molecular formula? If you remember, well, let's calculate the molar mass of the empirical formula. It's going to be 8 times the molar mass of carbon plus 9 times 1.008 plus 14.01 plus 2 times 16. Those are all the numbers from the periodic table. My molar mass is 151.2. And in the problem statement, my molar mass is 151. Because those two match, my empirical formula is my molecular formula. And the only thing left to do is go to the internet and find its common or generic name. Any questions about that? All right, I'm going to put it back up in just a second. Let me stop recording.